Hi everyone. Now we are going to discuss about Unit 4 notes. So basically this is the syllabus and first one starts with construction of DC generator or DC motor, which is basically called as DC machine. So construction of DC generator and DC motor is same. If they ask DC machine also, you have to write the same thing. So it has totally 9 parts. All of you can see here, these are the 9 parts which you have to write. And you can see here, this is the eye bolt which is used to lift the machine because it is very heavy device. They just keep an iron rod inside that circular one and then they lift it. The outside part is yoke, and later it has poles, and the small circular arc kind of thing is called as pole shoe. And you have field winding on a the windings are there, and these are called as field windings to which you give the supply, so that you get a magnetic poles, electromagnetism is produced, electromagnetic poles is produced. So that's all about the stator. Coming to the rotor, you have an armature, and this inside the armature you have the commutator, and you have the shaft also. So this diagram you have to definitely draw and explain each and every part of it. Now coming to the yoke, yoke is an outer frame which supports this pole shoe, and it is also used to cover what all the happening, and it provides mechanical support for the pole and pole shoe. It is made up of cast steel and cast iron, and as I said, it has inbuilt pole and pole shoe in order to reduce, it is made of cast iron or cast steel. So we try to reduce the reluctance is just like resistance, but in magnetism way we call it as reluctance. And resistance and current, whenever resistance is less, current is more. So reluctance is low, the flux is going to be high. In order to encourage more amount of current to pass, we try to reduce the reluctance, or we take such a materials which has low reluctance actually. And as usual, because it is an outer structure, it protects the inner parts of the machine. Now pole core and pole shoe which are fixed to the yoke actually, and they are fixed up to the yoke with the help of a bolts, mechanical bolts. They are made of cast steel iron, and they are made of with laminations, and in order to reduce the eddy current losses which are in the core. And they carry the field windings, all of you. So pole, on the pole we have the field windings, and because of the gravity it can come down, so we keep a circular structure so that the windings will not fall down. And pole shoe, a pole shoe carries a particular shape to enlarge the area of the armature core, so it also covers the armature. And later, field windings. The windings which are done on the pole are called as field windings. Actually, they are magnetic fields with a produced magnetic field, either north pole or south pole, and that's why they are called as field windings or magnetic field windings. Actually, they are wound on the poles in series connection, or parallel connection, or compound connections. So armature core and windings. Armature is a circular one by the cross section, but it is totally cylindrical one, and it is a laminated cylinder again, and it is placed on the shaft. Now all these things which we discuss are placed on the shaft, and it has slots on which the conductors are placed. And it also produces, because it is made of cast iron or cast steel, it produces low reluctance path. So it is made of silicon steel material. On the slots, we have the armature windings. Armature windings are the conductors which are being wound on the armature. They are being wound on the armature by two types. One is lap winding, the other one is wave winding. Lap winding, and the parallel path, later you will study about parallel paths, which is designated by A for the conductors. And if it is a lap winding, A is equal to P. And if it is a wave winding, A is equal to 2. If it is a lap winding, A is equal to P. Commutator is like just like a circular one which is connected to the armature shaft actually. So it is a wedge like one. So it rotates along with the armature, and it performs two things. It collects from the armature and it also supplies the current to it. It converts AC to DC in generator and it converts DC to AC in the motor. So that's what it is going to do. It is going to do. Now to the commutator, on the outside of the commutator you have brushes which are made of graphite, and they collect or they give the current to the commutator. That's the main purpose of them. So they give a current or power to the armature. Later we have the bearings. Ball bearings are there, roller bearings are there, because in order to make the armature to move freely we have the bearings. And later we have end covers. So end covers are the one which on which the bearings are being done, and they just close the machines because it is a rotating part. There is a chance, like, people can touch it, and because it is a rotating part it has to be closed. So we close by end covers. Front side end cover, back side end cover is there, and on top of it you have the yoke cover also, so that the machine is totally closed, the rotating part is totally closed. And whenever we close it, the projecting part comes outside. The projecting part is called as shaft. They are connected to the ball bearings, and shaft is made of this mild steel, and they have the maximum strength because they have to be connected to mechanical load, and they convey transfers mechanical energy either to the machine or either to the machine generator or motor. Now, coming to the working principle of DC generator, if you want to write the working principle of the DC generator, you don't have to remember anything. You just look at the fan on your head. So it is exactly opposite to the principle of the fan. For the fan, you give electrical energy, it produces mechanical energy. It is a motor principle. The generator is exactly opposite. You give mechanical energy and it produces electrical energy. So that's all. It is based on the Faraday's laws of electromagnetic induction. What did he say? So you can see here North Pole and South Pole, and I give supply. Whenever I give supply, whenever I give supply to the supply, and I give it to the commutator, this commutator gives supply to here. One conductor is there. We have North Pole, South Pole, and the lines represent magnetic flux. Whenever current carrying conductor cuts the magnetic field, whenever a current carrying conductor cuts the magnetic field, EMF is induced in it. So what happens? I make the conductor to rotate. I give mechanical energy, and this is the EMF. And here in the voltmeter, you can see that there is an EMF being produced. So whenever current carrying conductor cuts the magnetic field, EMF is produced. So mechanical energy, I rotate it. So whenever I rotate, you can see EMF is produced. So that EMF, based on the commutator, we get only one half cycle, which is a DC value, which you have studied in electronics. So mechanical energy rotates the armature, creating motion between the coils and stationary magnetic field. So that's what it is done. This armature cuts the conductor of the magnetic lines of flux, creating AC EMF in the armature coil. Positive cycle, negative cycle, positive cycle it produces. But what commutator does? It has split rings. So one ring will produce positive. The other ring, which deals with negative, also produces positive. So negative, positive, negative, positive, it is going to come, and we have the voltage only in one direction, one positive, one a half cycle only, positive half cycle only. That is called your DC value, and it is going to tell about three things. One is motion. Fleming's right hand rule describes about DC generator. The thumb is for motion, the forehand is for field, and the middle hand is for the current. So three are perpendicular to each other. Motion is mechanical energy, field is magnetic energy, current is electrical part. So that's what it is. Now we go across this. Now what is the EMF produced? EMF produced in DC generator is given by P phi NZ by 60A. So phi is flux, all of you can know about it. P is number of poles. N stands for speed at which you rotate, you give the mechanical energy. Z stands for number of conductors which are present in the armature. A stands for parallel paths actually. In parallel paths, I already said you, whenever it is lap winding, its value is going to be P. Whenever it is wave winding, then its value is going to be equal to 2. Now coming to the principle of DC motor, the first statement is from the fan itself directly. No reverse operation of the fan. It is directly from the fan. I give electrical energy, it produces mechanical energy. So it works on the Lorentz principle. So you have a current carrying conductor which is placed in magnetic field, and both of the magnetic fluxes they interact with each other and they rotate. You can see here this is the current and here is your magnetic field. So this magnetic field and its own magnetic field they start interacting, and then finally it starts rotating. Force is there and also speed is there. It starts rotating actually. You have to definitely draw this diagram. So you can see, so when the field windings wound on the poles are excited by DC source, the poles get magnetized. So you have north pole and south poles to be produced. It is very strong magnetic field. In that field, I place a conductor which has its own magnetic field, which is a small conductor, weak magnetic field. And due to interaction of these fields, resultant field is produced as like in figure C. So the resultant figure causes the rotation of the conductor. The direction of the conductor can be found by Fleming's right hand rule. I mean left hand rule. Left hand rule is also says the same thing. Thumb is for mechanical energy. Forehand is for magnetic energy, and middle finger is for forefinger is for magnetic field, and middle finger is for the current. Okay. And now according to your syllabus, we go to the next one called performance characteristics. This is all about the graph. Whenever it is being said like characteristics, you draw graphs actually. So you find what are the graphs you are going to draw. Torque and armature current. IA stands for armature current characteristics. Speed and armature current characteristics. Torque speed characteristic is the final one which you are going to draw. So in order to draw this graph, you have to understand few equations. The torque equations which we get from the DC motor is given by this, and EMF equation we already studied, it is given by this. And the back EMF equation is given by EB is equal to V minus IA into RA. So now in this one torque is given, so you can see here this is EB torque is EB is called as back EMF, IA is called as armature current. EB is equal to 5 ZNP by 60A. If you change the things, phi is, once a motor is designed manufactured, phi is constant, Z is constant, P is constant, 60 and A are constant. Only the value which are going to change is phi and N. Phi is not a constant. Later it becomes constant slowly. So what about N? N is equal to EB by phi. So N is equal to EB by phi. But EB is equal to V minus IA into RA. I substitute this equation here. N is equal to V minus IA into RA divided by phi. So in shunt motor flux is constant. So N is equal to V minus IA into RA. Now go with the torque. Torque all are constant. So torque is proportional to IA. I can write it as torque is proportional to phi into IA. So torque is proportional to IA. So now basing on this equation, we are going to get the equations. Torque is proportional to IA. So torque speed characteristics. Basing on torque is proportional to Ia, we have a straight line passing through the origin. This is called as armature torque. And we have a dotted line. Whenever this armature torque reaches the shaft, there is a delay. So that delay is designated by this line, this, because, when armature current increases, torque has not put up, torque has not put up, torque has not put up. And when armature current reaches at one value, torque has put up, and it is going to be linear value from that time onwards. This is called as shaft torque. So these two graphs you have to show. Now we go with the next one, speed versus IA characteristics. As we have discussed, N is proportional to EP, N is proportional to V minus IA into RA. V is a constant value, so minus IA into RA. So whenever speed is going to increase, this minus IA characteristics is going to come down. Ideal characteristic has to be like this. IA should be proportional to the, IA should be constant value, but IA keeps dropping down, and it is called as a drooping characteristics. No, speed torque characteristics. Torque is proportional to 1 by n. So they are inversely proportional to each other. So whenever torque increases, speed obviously comes down. So with this, the DC part is over. So in the next topic, we'll discuss about construction of three-phase induction motor. Thank you all of you.